Hi, it's Dr. Z. In this video, I will be reviewing frequency tables for ungrouped data. By the end of this video, you'll be able to describe a frequency distribution, create an ungrouped frequency table, and calculate several key concepts from an ungrouped frequency table. Please feel free to pause the video at any time to take notes. A frequency distribution is an important part of descriptive statistics. We organize a large set of numbers to better describe and understand the data. The root word of frequency is frequent, which refers to how often a value comes up in the dataset. In other words, how frequently the number appears. The textbook introduces the concept of distribution. Distribution is just a fancy word for how scores are spread out or distributed across a table or graph. When you hear the word distribution, just think about a table or graph. In other words, a frequency distribution is a technical term for describing data that is organized in a table or graph. In this video, we will learn about ungrouped frequency tables. Let's start with a group of numbers, or a data set as an example. You do not need to write these numbers down. These numbers are a sample of syllabus quiz scores from a previous semester. If you recall that the syllabus quiz score is worth 30 points, what observations can you make from this group of scores? Well, there are a lot of 30s, which is a perfect score. That's awesome. However, there's a couple scores of 28 and 29, which honestly is a bit concerning since students are allowed to use their syllabus to complete the quiz. As a researcher, how do we organize this group of numbers? Descriptive statistics involves organizing the number values in a way that allows the researcher to visualize any trends in the data. The easiest way is to organize these numbers into a table. We will organize the data from the previous slide with a frequency distribution. Let's break this concept into two parts. The root word of frequency is frequent, which refers to how often a value comes up in the dataset. In a dataset, frequency is the number of individuals in each category, such as how many students scored a 30 on the syllabus quiz. In statistical notation, we will shorten frequency to a lowercase italicized f. Distribution is just a fancy word for how scores are spread out or distributed across the sample. Distribution is a technical term for a table or graph of numbers, where the table shows how the numbers are distributed. When put together, the definition of a frequency distribution is a table or graph that shows a pattern of frequencies over various values. This photo of a Lego camera is a reminder that frequency distributions are like a photo snapshot of the data, so you can see all the data for a variable at once. We will now learn how to construct a frequency table. There are two types of frequency tables, for ungrouped data and for grouped data. There is a separate lecture video that describes how to create a grouped frequency table. When constructing an ungrouped frequency table, there are two steps. Step 1 is to create two columns, where one column will be labeled scores and the second column will be labeled frequency. Recall that statistical notation for scores is the letter X, and that notation for frequency is the letter F. Step 2 is to organize the first column with X scores from lowest to highest values. This step has an important clarification. You should include x values that are not represented in the data set if there are x values above and below them in the same data set. This clarification will make more sense when we review the practice example. The practice example is to organize the syllabus quiz scores shown earlier. Recall that x value is the quiz score, and the frequency value reflects the number of students who earn that specific score. The syllabus quiz scores are also listed here. I encourage you to pause the video and attempt to create an ungrouped frequency table on your own using the steps provided. Resume the video when you're done to review your answer. Step 1 is to create the frequency table with 2 columns for X and F. Step 2 is to organize the X scores from lowest to highest values. The lowest score in the data set is a 26. So we'll have a 26 in the table. The next score in the data set is a 28. So there's no score of 27. But wait, if there are X values above and below 27, then you must include the score of 27 in the table. Then we'll have the scores of 28, 29, and 30. Frequency is the number of individuals in each category, such as how many students scored a 26 on the syllabus quiz, which in this case is 1. There were no students who scored a 27 on the syllabus quiz, so F is 0. 4 students scored an X of 28. 4 students scored a 29 on the quiz, and 9 students scored an X of 30. Congratulations! You created your first ungrouped frequency table. We're now going to build on this new knowledge of ungrouped frequency tables and add in previous Legos that you learned about statistical notation. In a previous lecture video, you learned that statistical notation is the language of statistics. It is easier to shorten values in common statistical terms to a single letter for mathematical purposes. To calculate n from a frequency table, you will need to remember that n stands for the total number of individuals in a sample. In other words, n equals the sum of all the frequencies. Recall that the Greek letter E, called sigma, stands for the sum of. Therefore, the formula for n is n equals the sum of f. The practice example is the syllabus quiz scores in the ungrouped frequency table that we created earlier. How many students took the syllabus quiz? In other words, what is the n for this practice example? I encourage you to pause the video and attempt to answer this question on your own using the steps provided. Resume the video when you're done to review your answer. For this example, we use the formula n equals the sum of f, which means that we will add all the frequencies together, which is 1 plus 0 plus 4 plus 4 plus 9. So the answer is 18. A total of 18 students took the syllabus quiz. The box indicates the final answer. Well, let's take it up a notch. In a previous lecture video, you learned about sum of x. There are 2 methods to calculate sum of x. Method number 1 is the longer version, yet it helps students understand what sum of x is asking for in an ungrouped frequency table. Recall that sum of x is referring to the sum of all the x scores. Step 1 is to list out all the individual scores from the ungrouped frequency table. Step 2 is to calculate sum of x. The practice example here is an ungrouped frequency table that describes the vocabulary quiz scores of students in an advanced Spanish course. Quiz scores range from a perfect score of 5 to a score of 1. According to this table, one student scored a perfect score of x equals 5. So, what is the sum of x for this practice example? The most common mistake that students make is they want to add up the values in this x column, and they want to add up 1, 2, 3, 4, and 5. That is not what sum of x means. Sum of x means that you need to add up each individual score, which means that you need to take the x scores out of the frequency table. For instance, in this table, 3 students scored a 3 on the quiz. So there should be 3 3s in the data set. I encourage you to pause the video and attempt to answer this question on your own using the steps provided. Resume the video when you're done to review your answer. For this example, step 1 is to list out all the individual scores. 1 student scored a 1, 3 students scored a 2, 3 students scored a 3, 2 students scored a 4, and 1 student scored a 5. Step 2 is to add these values together to get the sum of x equals 29. The box indicates the final answer. Method number 1 works well for ungrouped frequency tables with small frequency values. Method number 2 is faster and works better for ungrouped frequency tables with larger values. This method requires a new formula. Sum of x equals the sum of fx. This formula asks you to multiply each f value with the corresponding x value and then add them up. Step 1 is to add a new column to the original frequency table and label the column fx. Step 2 is to calculate fx for each value, or to multiply each x by f. Step 3 is to calculate the sum of fx, or to add up all the fx products. The practice example is the same ungrouped frequency table of vocabulary quiz scores. I encourage you to pause the video and attempt to answer this question on your own using the steps provided. Resume the video when you're done to review your answer. For this example, step 1 is to add the fx column. Step 2 is to calculate fx, which is to multiply x by f for each value. So 1 times 1 equals 1, 2 times 3 equals 6, 3 times 3 equals 9, 4 times 2 equals 8, and 5 times 1 equals 5. It is these fx products here that you will add up in step 2. Using the formula, you will add up 1 plus 6 plus 9 plus 8 plus 5. And the answer is sum of x equals 29. The box indicates the final answer. Note that sum of x is the same answer for both method 1 and method 2, because each method is still asking you to calculate the same thing, sum of x. In summary, frequency tables are a feature of descriptive statistics. where we need to organize and summarize the data. Learning how to create an ungrouped frequency table is one of many important Lego building blocks needed to understand statistics.